Hi, I'm Tilda, and I want to talk to you about something that might make you uncomfortable. Those green check marks we all love to see in our CICD pipelines, where all of the tests are passing, builds are successful, everything looks perfect. But here's the truth. Sometimes everything can look green while serious problems are hiding underneath. I've maintained and contributed to several open source repositories, both small and large, and I've seen what happens when teams put too much trust in automation and not enough in human judgment. Today, I'm going to show you what CICD can't catch, and more importantly, what we can do about it. Now, I'd like to start with a story from March 29, 2024. Andres Freund, a Microsoft engineer, was doing routine performance testing. He SSH'd into a Debian system and noticed something odd. Authentication was taking a few hundred milliseconds longer than it should, and CPU usage was spiking during the handshake. Now, that might not sound like much, but when something that should be nearly instant suddenly feels off, experienced engineers need to pay attention. When he investigated, he found that the tests were passing, CI/CD pipeline was free, and the code had gone through normal review. So from the automation's point of view, everything looked fine, but something was very wrong. That disconnect between what our pipelines tell us and what's actually happening is what this talk is about. But before we go further, I'd like to establish why I'm talking about this. My name is Tilda Udufo. I'm a software engineer and program organizer at Outreach. And my role has involved coordinating code reviews across multiple open source projects, some with hundreds of contributors and lots of pull requests to review. And at that scale, you start to see patterns. You see where automation works brilliantly, and you see where it completely falls apart. You watch trusted contributors emerge, reviewers get overwhelmed and burnt out, and green marks creates a sense of false confidence. That experience is what I'm bringing to this talk today. But I'd like to frame this talk in three parts: the why, what, and how. Now, why does this matter? This matters because CICD can show green pipelines while there are fragile assumptions, risky changes, and subtle regressions that can still slip into production. So the automation doesn't tell the whole story. Now, what's the problem? Automation enforces the rules we defined, but it can't reason about intent. It doesn't understand context or pick up on social dynamics or what is when reviewers are overloaded. These human factors become critical as systems and teams scale. Now, the question is, how do we fix it? We are going to explore pairing automation with human safeguards, structured reviews, risk checklists, stage rollouts, and a culture that rewards slowing down when something feels uncertain. Now, let me clear this up front. This is not an anti-automation talk. I love CICD. I know how powerful and necessary it is. But at the same time, it's not sufficient on its own. And that's what we're here to explore. Now, here's a scenario you've probably lived through. The tests are green, your builds are successful, the deployments complete without errors. Everything your automation can measure says we are good to go. And then your users start to report issues. Now, this is the moment that makes us question everything. We followed the process. We did everything right according to our tools, but something still went wrong. So this gap between automation confidence and production reality, that's what we need to understand. So let's go back to that story from March and actually understand what happened. This wasn't just a performance bug. The executive's backdoor incident has been widely described as one of the most significant and sophisticated supply chain attacks that we've seen publicly discussed. And it wasn't found by a security scanner. It was found during routine performance testing because a small anomaly triggered a deeper investigation. Let's take a look at the timeline. In 2021, someone who called themselves Jiatan appears in the executive's project. They make helpful contributions. Nothing suspicious, just another contributor trying to help. By 2022 and 2023, after a year of consistent quality work, Jiatan gets commit access and becomes a maintainer. This makes perfect sense because they've proven themselves through legitimate contributions. Then in 2024, the backdoor is discovered completely by accident. Now let's take a look at what this bypassed. All tests passed. Code was reviewed. CICD was green. And so the question is, what actually failed here? It wasn't the tests, it wasn't the automation. What failed was trust management at scale. This was a social engineering attack that understood something fundamental. Automation checks code quality, but humans are supposed to check intent. The attacker knew that if you build trust over years, if you become part of the team, eventually people will stop scrutinizing your changes as carefully because you've gained their trust. This is the blueprint for attacking software at scale. Now let me break down what actually enabled this attack because it's not what you might think. First, the maintainer was overloaded and stretched thin. Now this is a common open source problem. It's one maintainer and hundreds of contributors, thousands of lines of code to review, and eventually maintainers get burnt out. Second, subtle changes slipped through over time. It wasn't one obvious backdoor, but it was incremental changes that individually looked harmless. Third, a long trusted contributor had gained significant influence. Years of legitimate contributions had built real trust, and that trust was weaponized. And finally, which is the critical point, automation did not see the social dynamics. It couldn't detect that trust was being systematically built and then exploited. It couldn't notice that review quality was degrading under pressure. So these are human problems, cultural problems, organizational problems, and no amount of automated testing catches these issues. So why do we fall into this trap? Why do green check marks give us such false confidence? There are four main reasons. First, green checks feel like certainty. There's that visual feedback that is psychologically satisfying. It gives us confidence, sometimes more than is warranted. Second, teams scale faster than review capacity. You can hire 10 engineers and they start one day, but building 10 experienced reviewers, that takes years. Review capacity lags behind team growth, so we use CI as a crutch. Third, deadlines push speed over caution. When the pressure is on, CI passing becomes the only approval gate that really matters. It's green, so we ship it, and that becomes the reflex. Fourth, we confuse necessary with sufficient. CI passing is a necessary condition for shipping code, but we treat it like it's a sufficient condition. It's not, and this is a logic error that we make constantly. If you've ever approved a PR, mainly because CI was green and you're rushing, you'll be able to understand this problem really well. But before we go deeper into the problems, let's be precise about what CICD actually does, because this framing is very important. CICD answers one question really well. Does this code meet the rules we defined? Does it compile? Does it pass our test, follow our style guide, satisfy our linting rules? CICD is brilliant at answering those questions. It's deterministic, consistent, and fast. But here's what it doesn't answer. Is this change safe in the real world? That's a very different question from the question about meeting the rules that have been defined. It requires judgment, context, and understanding that goes beyond what we can automate. So we need to stop treating these as the same question. Now, let me be absolutely clear and repeat again. I love CICD. I think it's one of the best things that has happened to software engineering in the last 20 years. Because look at what it gives us. Repeatable, reliable builds. Same input, same output every single time. Consistent checks and linting. Style enforcement and basic quality checks are all automatic. Automated testing, regression, prevention at scale. This alone has saved countless hours and prevented countless bugs. Faster deployments. We can ship multiple times a day instead of once a quarter. This is transformative. Reduce human error. No more forgetting manual steps or skipping items on deployment checklists. This is all revolutionary, and because of CICD that we are able to do this. So CICD is very necessary. I cannot begin to stress that enough. But necessary doesn't mean sufficient. And that's the key distinction that we need to internalize. Now let me show you what CICD fundamentally cannot catch. Not because it's poorly configured, but because these things are outside its scope by design. Number one, social engineering. A trusted contributor changes employers. Their priorities and their motivations have shifted, but their trust level in your repository stays exactly the same. CICD can't detect this. Number 2, subtle performance regressions. Your query works perfectly with clean test data. But in production, with millions of rows, it does a table scan that crushes your database. Test passed or production burned. Number 3, integration behavior across system. Your service passes all its tests. It works great in isolation, but in production, it causes timeouts in 3 downstream dependencies your test environment doesn't know about. Number 4, UX and workflow mismatches. The feature works. It does exactly what it specs it, but it completely breaks the user's mental model of how the system should work. Users are confused and frustrated, but all of the tests are passing. Number 5, risky dependency changes. You upgrade a library, the upgrade is fine. But it brings in a new transitive dependencies with known vulnerabilities that your scanner missed because it only checks direct dependencies. Number 6, misconfigurations that look harmless. You change one environment variable. This is completely fine in staging. In production, under real load, it causes memory leaks that takes hours to surface. Every single one of these is a predictable systemic gap in what automation can detect. And these are not edge cases. These happen constantly. Now let me show you something that explains why the XC attack worked and why these problems get worse as projects grow. Trust doesn't scale linearly. It breaks at predictable points. At 5 contributors, personal trust works perfectly. You know everyone, you understand their code style, their judgments, their motivations. Review is straightforward because you have context for everything. At 50 contributors, people are semi-known. You recognize the regulars, but there are people you've never met. Friction starts to appear. Review takes longer because automatic trust is gone. At 500 contributors, your trust model is completely broken. Most prayers come from strangers. You have no idea about their motivations, background, or skill level, but you still need to review and decide whether to merge. This is where the XC maintainer was. They were overwhelmed, dealing with hundreds of contributors, burning out. And that's when Giatan appeared with years of legitimate contributions and offered to help. So here's the paradox. As your project succeeds and grows, the trust model that enabled that success becomes your biggest vulnerability. So why do these problems get worse over time instead of better? First, more contributors equals more assumptions. Every new person brings different standards, background knowledge, and risk tolerance. Implicit understandings don't transfer, they don't scale. Second, automation hides fragile processes. When CI is green, it creates false confidence that everything is fine. Problems in your process, culture, and trust management become invisible because the automation is passing. So green checkmarks effectively hide systemic dysfunction. Third, review becomes rubber stamping. When reviewers are overloaded with 80 PRs in the queue, review becomes a checkbox. CI pass becomes the only criterion. So you're not really reviewing anymore. You're just making the queue number go down. Fourth, trust grows faster than oversight. We grant access based on velocity of contributions, not the depth of review. So someone makes 20 small PRs that look fine. Do they get merge rights? But did anyone actually audit those changes deeply? Probably not. So these aren't individual failures. These are systemic dynamics that emerge predictably as teams grow. Now let's talk about the organizational pressures that make all of this worse. Pressure 1, review queues are piling. 100 PRs are waiting. There are more coming daily. Reviewers become the bottleneck. Complaints start about slow reviews. Quality suffers under volume. Pressure 2, approvals happen under time pressure. The deadline is tomorrow. The project manager is asking for updates. The CEO mentioned this feature to the board, so you start to approve without fully understanding. Trusting the tests cut any issues. Pressure 3, just ship it becomes the norm. Speed becomes the dominant metric. Velocity, deployment frequency, cycle time, these get measured and rewarded. Caution is not something that appears on the dashboard, so it stops being valued. Pressure 4, maintenance becomes reactive. All energy goes to firefighting. There is no time for prevention, process improvement, or learning. You are always in crisis mode, cutting corners and skipping steps. These pressures are universal. So the question now is, do your safeguards still work despite these pressures? Or are they the first thing that gets sacrificed when pressure increases? So let me show you specific processes that break under pressure. First, single reviewers for critical code. One person approves authentication changes, one person owns payment processing, one person handles infrastructure. When they are overwhelmed or on vacation or leave the company, all of that knowledge walks out the door. Second, unwritten tribal knowledge. The rules aren't documented. New reviewers don't know which areas are dangerous, which patterns are banned, which shortcuts are acceptable. Critical context exists only in senior people's heads. Third, informal rules about approvals. Who can approve what? It depends. On what? On who you ask. Trust is granted inconsistently. Nobody is quite sure what the actual standard is. Fourth, no ownership for risky areas. Security, infrastructure, data migrations, performance critical code. Everyone assumes someone else is watching carefully. But the spoiler is, nobody is, because nobody was assigned to. Everyone just assumed someone else would. This tribal knowledge problem is nearly universal and it's invisible until it breaks. So, we've talked so much about problems. Let's talk about solutions. I'm going to give you a framework built on 3 pillars. Think of these as complementary to automation, not replacements for it. Pillar 1, review practices. How you actually review code. Who reviews what and what standards you apply. Pillar 2, process. The structural and technical safeguards you put in place to catch what human review might miss. Pillar 3, culture. The attitudes, incentives, and norms that determine whether people actually use these practices or route around them under pressure. All 3 need to work together. Great process without culture creates ignored processes. Great culture without process doesn't scale. And neither works if your review practices are weak. So let's explore each one. First pillar, review practices that actually scale. Here are 4 things you can implement immediately. Number 1, second reviewer for high-risk areas. Things like authentication, payments, security critical code. These need 2 sign-offs from people with relevant expertise, and this should be a non-negotiable for critical paths. Number 2, rotate reviewers to avoid power concentration. Don't let the same person review the same author twice in a row. Fresh eyes catch patterns. And this prevents both intentional gaming of trust, like we saw in XC, and unintentional drift, where standards gradually relax. Number 3, use risk checklists before merging. Before clicking merge, answer a series of questions. Does this touch off? Are there new dependencies? Is rollback step there? Multiple yes answers signal you should slow down. Number 4, separate fast lane versus slow lane PRs. Not everything needs the same scrutiny. Things like documentation fixes, test improvements, error full coverage, these can move. New things like new features, dependency upgrades, performance optimizations, these can move slower. So make this distinction explicit and systematic. So the key insight here is, not all code is equal, not all reviewers are equal, and not all circumstances are equal. You need differentiation. One size fits all doesn't work at scale. Second pillar, cultural safeguards. This is where most organizations fail. You can have great processes, but if culture doesn't support them, people route around them. First thing, normalize asking questions. Make, I don't understand. Can you explain completely acceptable in code review? It is not a sign of weakness or slowness. It is a sign that you are doing your job properly. Number 2, reward caution, not just speed. If your metrics focus only on velocity, if bonuses are tied only to how fast deployments are made, and if only the engineers shipping the most features get promoted, what behavior are you incentivizing? Explicitly reward people who catch issues before production. Number 3, document issues openly. When you make a technical choice, accept a trade-off or waive a requirement, write it down. In the PR, whether it's in the commit message or design doc, make sure that reasoning is visible and reviewable. Number 4, peer-reviewed tricky changes. For genuinely complex PRs, like things like major refactorings, architectural changes, subtle bug fixes, have two reviewers work together synchronously. That way you can catch more issues, share knowledge, and build common understanding of quality. Culture beats process every time. So if your culture says, just ship it, your processes won't be able to save you. Now, this slide is my favorite in the entire deck. It's a risk checklist you can start using today. So before merging any PR, answer these questions. Does this touch sensitive areas in the project, like auth or infrastructure? Are any new dependencies being added? Are hard-to-test code paths changed? Is rollback simple? Is reviewer new to this area? Does this rely on tribal knowledge? Are we merging under time pressure? What could go wrong if we are wrong? Now here's the key. Yes answers don't mean don't merge. They mean slow down. Get a second reviewer, add monitoring, plan the rollback procedure, document your assumptions, maybe even stage the deployments. That last question is the most important. What could go wrong if we are wrong? If you can't answer that question, you probably don't understand the change well enough to approve it. So the goal isn't to prevent all risks. It's making risks explicit and conscious instead of implicit and invisible. Third pillar, technical and process safeguards that extend CICD to catch what tests can't. Number 1, canary deployments. So don't just go straight from test pass to deploy to everyone. Deploy to 1% of traffic first. Monitor it. Watch for errors, performance issues, user complaints, and scale up gradually. Number 2, post-deployment smoke checks. After deployment, automatically run checks against production. Are the users able to log in? Can they complete critical workflows? Are response times normal? These catch integration issues that tests miss. Number 3, monitoring tied to releases. Every deployment should create markers in your monitoring system. This makes it easier to see if error rates spiked after that deploy. Number 4, dependency anomaly alerts. When someone adds or builds a dependency, automatically check. How many other dependencies does this bring? How old are they? Are there any known vulnerabilities? How many maintainers? This catches supply chain risks before they become XE-level problems. Number 5, error budgets and rollback triggers. Define them in advance. If error rates exceed X, automatically rollback. If latency exceeds Y, automatically rollback. No discussion needed, just automatic rollback. And then investigate after stopping depleting. These aren't expensive or complicated. They are systematic application of one principle, which is test in production, but carefully. Now let me show you what this looks like in practice. Before, the PR arrives, test run, merge, deploy. 4 steps, very fast but fragile. Now, this is what our after is looking like. PR arrives, tests run, risk check happens using our checklist. Then it goes to appropriate reviewers based on risk level. Then stage deployments, canary first, then gradual rollouts. Then monitoring during rollouts with automatic rollback triggers. More steps? Yes. Slower? Maybe. But here's what matters. Low risk changes still move fast through the fast lane. The only thing you've added is overhead where risk justifies it. And critically, you've also created multiple opportunities to catch issues before they cause problems. This is defense in depth. No single safeguard is perfect, but the combination makes it much harder for issues to slip through. You are not slowing everything down. You're just being selective about where you add rigor. So let me bring this full circle with 4 takeaways. 1, CICD is necessary but not sufficient. Automation is powerful, essential, but it's not the whole answer. 2, risk grows quietly as projects scale. What works at 5 contributors fails at 500, so you need to be able to actively adapt. 3, people and process fill the gaps automation can't. Intent, context, trust, judgments, these require human solutions, not just technical ones. 4, Safeguards don't need to slow delivery. You can maintain velocity while improving quality. They are not in opposition. Remember Andre's friend on March 29th, 2024? He noticed something that all of the automation missed. Not because he was smarter than the tests, not because he had better tools, but because he stayed curious. He questioned the green check marks. That's what saved us from executives. Human curiosity, human judgment, human caution. So your automation will keep getting better. Your CICD will keep evolving, but it will never replace the human who asks, wait, why? When something feels off. Build systems that support that human. That's how we are able to build resilient software. Thank you so much for watching. I hope this has given you concrete ideas to try with your own teams. And if you'd like to discuss any of this further, you can find me on LinkedIn and X as Tilda Udufo. Thank you so much.